Hi, and thanks for joining us in this discussion of the tools for inspecting running industrial fiberglass equipment. Inspecting fiberglass equipment while it's running is notoriously difficult. Metals technologies often just simply don't work very well because fiberglass is inconsistent, non-magnetic, low and variable density, and probably most importantly, it's highly permeable, which means that it changes density randomly with time. And basically its very makeup changes over time. Now, we've found that it's difficult but not impossible with the right technology. We've been working 30 years to isolate the best technologies and to develop their use, as well as to develop many of our own proprietary methodologies such as MFI. Anyway, we hope this discussion is useful and interesting, and look forward to working with you in the future. Hi, I'm Todd Bishop, owner of Brer Technical. Brer has been working on better ways to evaluate online FRP since the late 1990s, and I have been working on the problem since the late 1980s. We're here to talk about the things that we've developed and how we currently accomplish the goal of preventing loss and helping owners of industrial FRP decide when to repair or replace their aging equipment. Having effective equipment is needed, but it must also be practical. Analog is an example of this. It worked well, but the equipment and the process just wasn't practical. It just took too long. Digital changed all that. Lightweight, battery-powered, instant development, it just worked. As we see it, there are two functional objectives. The first need is to determine if the equipment is worth repairing at all. How damaged is the laminate overall? Obviously, if it's not sustainable, it should not be repaired. We call this technical damage, but it cannot be detected by visual or electronic observation. Physical strength testing is required to determine the technical status or remaining strength and flexibility of the laminate. The second and equally important reality is that even if the equipment is somewhere in the middle of its usable life, it may have localized defects that threaten to shut down the plant, cost production, or worse. These need to be addressed before they cause issues. The first thing is always visual inspection. It should not be the only thing, as in many cases, but it should be the first thing. We have a saying that you can't tell how FRP comes apart unless you know how it goes together. We believe in providing experience for visual inspection. Leaks, abrasion, improper design, support problems, they need to be identified and corrected if justifiable. The divot test is not really an online technology except in some very unusual applications. But it is an example how Brer and its founder has led the industry for decades. Divot was introduced in the early 1990s and is now part of the TAPI used equipment protocol. It laid out the details of the laminate surface quickly and it's easy to repair. Infrared or IR is a great pre-qualifying non-contact tool. We've been using it since it was nitrogen charged. IT finds blisters in the shell using heat, as in this slide, and is a great indication of thickness loss overall. This is a case where IR saved our customer hundreds of thousands of dollars all at once. This is a small but vital stock tower that was on the verge of total failure. We found it with IR, confirmed it with UT, and the mill was able to get a replacement in time for the outage. UT is an indispensable tool, most often used as a comparator for taking laminate thicknesses and conditions provided by other testing means, like X-ray, and seeing how widespread the damage is. We insist our inspectors use flaw detectors and not the common thickness gauge so that they can see the waveform and interpret the outcome. Brer fields 2 complete battery-powered pulse digital X-ray cameras and scanners. Shots take less than 15 seconds. The download is under 2 minutes. The need for bannering or patrols during the shot is minimized because of small exclusion zones and short exposure durations. These 2 images are of similar pipe sections. The one on the right is an intact corrosion liner. The one on the left has a corrosion barrier and part of the structure removed. X-ray is best on piping less than 16-inch diameter, but gives solid thicknesses and structural and corrosion barrier information up to 36-inch diameter depending on the thickness. It's also used in a different way on critical tankage to check the condition of the shell under nozzle reinforcement pads and to verify the current packing level in a running packed column, like a scrubber. This is a real monitored filament insertion or MFI test. It's all over in less than a minute. It was developed by Brer and built in-house. It's fully robotic, enters the data onto the report in real time, and provides information regarding the depth of saturation accurate to plus or minus 0.005 inches. It's the only blindside test method available that we are aware of that can accurately measure the depth of saturation, hence damage. MFI can be used as an exploratory tool or as a long-term monitoring system. This is a completed installation. On the right, the orange cap can be removed and the filament monitored throughout the remaining life of the equipment. This is an automated graphic of the MFI process. The tiny filament is inserted in the laminate without pre-drilling. It's sealed into place by the displaced material along the filament and is not removed. Brer Technical proprietary metered mechanical pressure, or MMP, is a direct way of measuring the hardness within a laminate using low pressure air acting on a relatively large piston area. Force is exerted onto the filament, causing it to press into the laminate depending on the hardness of the material at the filament's tip. Developed in-house, it functions like a Barkal hardness meter inside the laminate, the only means to do so that we are aware of. Again, the equipment is very portable, takes no less than a minute start to finish. Brer Technical ships all this technology and more in a house-developed pop-up work area that we call our mobile material labs. Things arrive intact and complete and ready to go to work on the morning of the first day. The crew is able to do critical office functions in the field near the work. Using the technology that we are describing and other advancements still in progress, Brer continues to more effectively determine the overall technical condition of the laminate and localize deficiencies before they shut you down. Thanks for taking this journey with us. Please contact us using the information on this slide. It's been a real pleasure, and we look forward to working with you.